Okay, today we're going to look at section 3.8, exponents. So suppose you want to multiply a number, let's label that number A, by itself some number of times. Let's label the number of times B. We can denote this as A to the B power. We say A is raised to the B's power. When we write or see 7 to the 5th power, we call 7 the base and 5 the exponent. What it represents is 7 multiplied by itself 5 times. This means exponents are used as shorthand for repeated multiplications, where we write 7 to the 5th is equal to 7 times 7 times 7 times 7 times 7. Or we could call it 7 to the 5th power. So now we look at some rules. First rule we examine is the product rule. If we have a to the n times a to the m, it is equal to a to the n plus m. When you multiply a base raised to a power times the same base raised to another power, the result is the base raised to the sum of the power. And here it is. Keep in mind that the product rule only applies when the bases are the same. If the bases are different, we do not apply this rule. If possible, use the product rule to simplify the following. Now we have 12 to the 13th times 12 to the 8th. Well, this is equal to this is equal to 12 to the 13 plus 8, which is equal to 12 to the 31st. Now we have 3 to the 6th times 4 to the 10th. In this case, we cannot simplify, not in this fashion. So use the product rule to simplify b to the 6th times b to the 3rd. Well, equal to b to the 6th plus 3, which is b to the 9th. Next, we have a quotient rule. If a number a is raised to a power n, is then divided by a raised to another power m, the result is a to the n divided by a to the m is equal to a to the n minus m. So when we're adding them, or when we're multiplying, we add the base or the exponents. When we're dividing, we subtract exponents. And note again that this rule only applies when the bases are the same. So if I have b to the 6th over b to the 4th, this is simply b to the 6th minus 4, which is b to the 2nd. Okay, another thing to remember is if you have a non-zero number a, then a to the 0 power equals 1. So anything to the 0 power is 1. Well, anything but 0. If you have a product, a times b, and raise it to an exponent n, then a times b to the n is equal to a to the n times b to the n. Please note this is a times b, not a plus b. The exponent distributive rule, an times bn equal to a times b to the n, only works if the equations are the same, or if the exponents are the same. So use the exponent distributive rule to expand 2 times 19 to the 14th. Well, this is simply 2 to the 14th times 19 to the 14th. And expand a times b to the 6th. Well, it's simply a to the 6th times b to the 6th. Okay, now, when you have a fraction, a over b, raised to an exponent n, then a over b to the n is equal to a to the n over b to the n. Use the exponent distributive rule to expand the following. So we have 14 over 5 to the ninth. Well, that's equal to 14 to the ninth power over 5 to the ninth power. A over 15 to the fifth power. That's simply a to the fifth power over 15 to the fifth power. Yeah, let's make that more of an a there. Okay. Next thing we have is called the power rule. If you raise a non-zero base, say a, to an exponent n, and then raise that to another exponent m, you get the base raised to the product of the exponents, which is, if I take a to the n and raise it to the nth power, that is essentially saying a to the n times m. So in this case, I have 11 to the 4 times 12, which is 11 to the 48. Here I have a to the 7 times 6, which is a to the 42nd. Okay, then we have our negative exponent rule. So now we've only looked at positive exponents. The last exponent rule we look at is what negative exponents represent. A to the negative n is equivalent to 1 over a to the n, provided, of course, that a does not equal 0. Likewise, 1 over a to the negative n is equal to a to the n. So we're going to convert the following expressions to expressions with no negative exponents. Well, 12 to the negative 3 is just 1 over 12 to the third, and then times 7 to the fifth. And we might even combine this to 7 to the fifth over 12 to the third. Here I have c to the negative seventh. So that's going to be 1 over c to the seventh times 5 to the third, and again, 5 to the third over c to the seventh. Use negative exponents to rewrite the following expressions with the denominator, with no denominator. So we have 13 to the 8. I change that to 13 to the negative 8. Then it's multiplication. 6 to the third. I have 2 to the ninth in my denominator, so that becomes 2 to the negative ninth times c to the fifth. Now here we have a partial list of the properties to review. Product property. A to the n times a to the m is a to the n plus m. A to the n divided by a to the m is a to the n minus m. A to the 0 power is 1, provided that a does not equal 0. Distributed rule, a times b to the n is a to the n times b to the n. And the distributive rule division, a over b to the n is a to the n over b to the n. And the power rule, a to the n to the nth is a to the n times m. And the negative exponent rule, a to the negative n equals 1 over a to the n, provided a does not equal 0. So now let's simplify this. So what do we have here? We have 7 to the ninth to the 8th over 10 to the 5th times 6 to the 3rd to the 8th. So this is 7 to the 9 times 8, which is 72. This is 10 to the 5 times 8, 10 to the 40th, times 6 to the 3 times 8, 6 to the 24. I think that's all we want. So here we have 4 squared. A to the ninth times 2 is A to the 18th. B to the 6th times 2 is B to the 12th. And that completes our exponent section.